So welcome students. Our next topic is conditional identities. So we have already seen trigonometric identities, right? Sin square theta plus cos square theta is equal to 1. Secant square theta minus tan square theta is equal to 1. Cosecant square theta minus cot square theta is equal to 1. So those are general identities which will be valid for every value of theta. So in this topic we are looking at conditional identities. That means these are also identities, but they have a condition before them. For example, if you have three angles ABC whose sum is equal to 180 degrees, if this condition is valid, A plus B plus C is equal to 180 degrees. If this happens, then there are some identities in ABC which will always be true. That is, tan A plus tan B plus tan C will always be equal to tan A, tan B, tan C. So if ABC are such that A plus B plus C is equal to 180 degrees, then tan A plus tan B plus tan C will always be equal to tan A, tan B, tan C. Cot A, cot B plus cot B, cot C plus cot C, cot A will always be equal to 1. Similarly, tan A by 2, tan B by 2 plus tan B by 2, tan C by 2 plus tan C by 2, tan A by 2 will always be equal to 1. Cot A by 2 plus cot B by 2 plus cot C by 2 is equal to cot A by 2, cot B by 2, cot C by 2. Similarly, in terms of sine, if A plus B plus C is equal to 180 degrees, sine A plus sine B plus sine C will always be equal to 4 cos A by 2, cos B by 2, cos C by 2. So you have, in this way, you have other identities also, as you can see here. So these are not the only identities that you have a lot of identities. These are just a schematic type of identities that I'm presenting here. So the thing that you need to understand in this topic is how to get these conditional identities, how to prove them. So in the examinations, you'll be asked to prove these identities, any of these identities, or any of the identities that I did not write here. You have a lot of different identities which can be proved. So let us look at the techniques by which you can prove these conditional identities. So it need not be that always A plus B plus C is equal to 180 degrees. A plus B plus C can be equal to 90 degrees. Then you have certain identities. A plus B plus C is equal to 360 degrees. You have some identities. So now let us look at the methods of proving this trigonometric conditional identities. So these processes are broadly divided into three categories. So let us look them one by one. So the first type of conditional identities are the conditional identities involving sine and cos. For example, if A plus B plus C is equal to 180 degrees, sin A plus sin B plus sin C is equal to 4 cos A by 2, cos B by 2, cos C by 2. Assume that you're asked to prove this result. So how do we go about doing this? So let us start with the LHS. So my LHS is sin A plus sin B plus sin C. That is equal to what is, so let me keep sin A separate. So what is sin B plus sin C? So we have a formula, sin C plus sin B is 2 sin C plus D by 2 cos C minus D by 2, right? So sin B plus sin C is 2 sin B plus C by 2 cos B minus C by 2. I have used the transformation formula from sum to product. So that is equal to, so now we use the condition that A plus B plus C is equal to 180 degrees. So if A plus B plus C is equal to 180 degrees, what is B plus C? B plus C is nothing but 180 minus A. And what is B plus C by 2? 180 minus A by 2. That is 90 minus A by 2. So sin A plus 2 sin 90 minus A by 2 into cos B minus C by 2. So now what is sin 90 minus A by 2? Sin 90 minus A by 2 is nothing but cos A by 2, right? That is equal to, sin A can be written as 2 sin A cos A plus 2 sin 90 minus A by 2 is cos A by 2. Sorry, sin A can be written as 2 sin A by 2 cos A by 2 plus 2 cos A by 2 into cos B minus C by 2. So now as you can see, in both of them you have 2 cos A by 2 as common. So I'll take 2 cos A by 2 as common. So what is left out? Sin A by 2 plus cos B minus C by 2. Now I'll again use the condition. What is A? A is nothing but 180 minus of B plus C. So A is nothing but 180 minus of B plus C, right? So what is A by 2? A by 2 is 180 by 2 minus sine of B plus C by 2. So now I want sine A by 2. So what is sine A by 2? Is nothing but sine of 180 by 2 is 90 minus of B plus C by 2. What is sine 90 minus theta? Cos theta. Cos B plus C by 2. So sine A by 2 is nothing but cos of B plus C by 2. So if I write cos B plus C by 2 in the place of this. So now you have 2 cos A by 2 outside. This looks like this. So now what is cos B plus C by 2 plus cos B minus C by 2? So what is cos C plus cos D? Cos C plus cos D is 2 cos C plus D by 2 cos C minus D by 2. That is equal to 2 cos A by 2 into 2 cos. What is the sum of this? The sum of these two is B, right? B plus C by 2 plus B minus C by 2. C by 2 and minus C by 2 are getting cancelled. B by 2 plus B by 2 is B by 2. Sorry, B by 2 plus B by 2 is B. So you have the sum is B by 2, you have formula. So cos C plus cos D is 2 cos C plus D by 2 into cos C minus D by 2. If you subtract one from the other, you get C by 2. So that is equal to effectively 2 into 2 is 4 cos A by 2 cos B by 2 cos C by 2. So effectively we have proved that sin A plus sin B plus sin C is 4 cos A by 2 cos B by 2 cos C by 2. The simplifications that we have done here will be valid only if A plus B plus C is equal to 180 degrees. That's why this is called a conditional identity. This identity is not always valid. Only if the condition is valid, this identity is valid. So now let us look at another question in the same model. So you're asked to prove that cos A plus cos B plus cos C is equal to 1 plus 4 sin A by 2 sin B by 2 sin C by 2 if A plus B plus C is equal to pi. Pi is nothing but 180. So previously we have proved sin A plus sin B plus sin C is 4 cos A by 2 cos B by 2 cos C by 2. Now you're asked to prove cos A plus cos B plus cos C is this. So this is also a conditional identity involving sin and cos. So how do we start? We start from the LHS. Cos A plus. So let us take cos B plus cos C. What is cos C plus cos D? Cos C plus cos D is 2 cos C plus D by 2 cos C minus C by 2. So you get both cos's. So cos B plus cos C is 2 cos B plus C by 2 cos B minus C by 2. So that is equal to. Now what is B plus C? B plus C is pi minus A. B plus C by 2 is pi by 2 minus A by 2. And cos A, let me write in the next step, 2 times, this is cos of 90 minus A by 2, right, into cos B minus C by 2. So as you can see, cos 90 minus A by 2 is sin A by 2. So you get a sin A by 2. So in the previous question, we have taken some terms as common in the next step. So what I do is that is equal to, I need a 1 here extra. So cos A can be written as, what's the formula for cos A? Cos A can be written as 1 minus 2 sine square A by 2, right? Because cos 2 is 2 cos square A minus 1 or 1 minus 2 sine square A. So cos A can be written as 1 minus 2 sine square of A by 2 plus 2 cos 90 minus A by 2 is sine A by 2 into cos B minus C by 2. That is equal to 1. So if I take a 2 sine A by 2 as common, so plus 2 sine A by 2, if I take it as common, I have a cos B minus C by 2 minus sine of A by 2. Sine of A by 2. So again, sine of A by 2 can be written as, because A plus B plus C is 180, so A by 2 can be written as 90 minus of B plus C by 2, right? So sine A by 2 will be cos of B plus C by 2. That is equal to 1 plus 2 sine A by 2 times cos B minus C by 2 minus of cos B plus C by 2. So cos B minus C by 2 minus cos of B plus C by 2. If you look at the transformation formula, this is exactly same as 2 sine B by 2 sine C by 2. This is 2 sine B by 2 sine C by 2. That is equal to 1 plus 4 times sine A by 2, sine B by 2, sine C by 2. So you have proved this identity. So in this way, whatever identities are given, by using the basic transformation formulas and the condition which is given, we can get the answers. We can get the proofs. Now let us go to the second type of questions. So the second type of conditional identities are conditional identities involving squares of sine and cos. The sine square and cos square. For example, if a plus b plus c is equal to 90 degrees, you are asked to prove that cos square a plus cos square b plus cos square c is equal to 2 plus 2 sine a sine b sine c. So how do we prove this? Let us start from the LHS. So the technique in the second type inequalities is nothing but we just try to convert type 2 into type 1 initially, because there are no identities in squares, there are no formulas involving squares. So transformation formulas are all involving normal trigonometric ratios. You have sin c plus sin d, sin c minus sin d, so on. What we do is we convert the squares into multiple angles. We have a formula which says that cos square a is equal to 1 plus cos 2a by 2. Similarly, cos square b is 1 plus cos 2b by 2, 1 plus cos 2c by 2. So if I put all this, so you get 1 plus cos 2a by 2 plus 1 plus cos 2b by 2 plus 1 plus cos 2c by 2. So this is the LHS, that is equal to 1 by 2, 1 by 2, 1 by 2 becomes 3 by 2 plus half of cos 2a plus cos 2b plus cos 2c. Half of cos 2a plus cos 2b plus cos 2c. So again, you can do the same process that we have done in type 1 for this question. So now let me use the identities that I have derived in type 1. So what is the identity that I have derived there? If a plus b plus c is equal to 180 degrees. So I have derived that if a plus b plus c is equal to 180 degrees, cos a plus cos b plus cos c is equal to cos a plus cos b plus cos c is 2 sin a by 2 sin b by 2 sin c by 2, right? In the previous question, this is what we have derived. So now, is this applicable here? So as you can see, a plus b plus c is equal to 90 degrees in this. So what is 2a plus 2b plus 2c? So if a plus b plus c is equal to 90 degrees, 2a plus 2b plus 2c will be equal to 180 degrees. So for 2a, 2b and 2c, can I apply this formula? Yes. So 2a plus 2b plus 2c will be equal to 180 degrees. This implies cos 2a plus cos 2b plus cos 2c is equal to 2 times sine of 2a by 2, that is a, sine b 2b by 2, sine 2c by 2. So that is equal to 3 by 2 plus half times, sorry, I have derived this as 1 plus this. So you have a 1 extra. So 1 plus 2 sine, 1 plus, this is, I've got it wrong. So 1 plus 4 sine a by 2, sine b by 2, sine c by 2. So now, so if I use this formula here, I get 1 plus 4 times, if you have a here, you have an a by 2 here. If you have 2a here, you have half of that. That is sine a, sine b, sine c. That is equal to, so 3 by 2 plus, if you expand the bracket, 1 by 2, which is 2 plus 4 by 2 is 2 sine a, sine b, sine c, which is the required RHS. So if you have knowledge of identities, you can solve these questions very easily. So you can use some of the identities which I have derived earlier, so in the subsequent derivations. So if you are given only this question in the examination, you have to do it completely. You have to do the same process as we have done when solving this. So cos 2b plus cos 2c, you apply the transformation formulas, then apply the condition, transform the angles, transform the ratios, use multiple angle formulas. You have to do all that is required. The third type of conditional identities involve tans and cotangents, tans and cots. For example, if you have A plus B plus C is equal to 180 degrees, you're asked to prove that tan A plus tan B plus tan C is equal to tan A tan B tan C, and cot A cot B plus cot B cot C plus cot C cot A is equal to 1. Suppose that you need to prove these two identities. So as you know, there are no transformation formulas in tans, so we cannot use the previous methods for these identities. So what we do for tans and cots, we start from angle, we start from the condition. So A plus B is equal to 180 degrees minus C, right? So if A plus B plus C is equal to 180, A plus B is equal to 180 minus C. Now if I want to derive the tan property, I apply tan on both sides. So tan of A plus B is equal to tan of 180 degrees minus C. So this implies, what is tan A plus B? Tan A plus tan B by 1 minus tan A tan B, compound angle formula, is equal to tan 180 minus C. So what is tan 180 minus C? We use T n pi by 2 plus or minus theta formula. So first, quadrant identification. 180, 2 times 90 minus something. So if you take the quadrant diagram, 2 times 90 minus something, that is in the second quadrant. In the second quadrant, tan is negative. So you have a negative here. And 180 is 2 times 90 degrees, even number. So tan remains tan, and you get C here. So now if I cross multiply this, I get tan A plus tan B is equal to minus tan C plus tan A tan B tan C. And if this tan C goes on to this side, I get tan A plus tan B plus tan C is equal to tan A tan B tan C, right? So tan A plus tan B plus tan C is tan A tan B tan C. So that's how I calculate that I have proved the first identity. Similarly, the same is the case with cot. So if I want to derive some identities regarding cot, I start from the angle, apply cot on both sides. So I get cot A plus B is equal to cot of 180 minus C, right? So what is the formula for cot A plus B? Cot A cot B minus 1 divided by cot A plus cot B is equal to cot 180 minus C. Again, the angle is in the second quadrant, so you get a negative sign. 180 is 2 times 90 degrees. So you have an even number with 90. So cot remains cot C. So if you do the cross multiplication, you get cot A cot B minus 1 is equal to minus cot A cot C minus cot B cot C. You see that you're getting the required identity. If you bring these two on this side, minus 1 goes on to that side. So cot A cot B plus cot B cot C plus cot C cot A is equal to 1. So in this way, you can prove the conditional identities involving tans and cots. You start with the angle, you go forward. You apply trigonometric ratio on both sides, you go forward. If the identities involving sine and cos, we use transformation formulas. If they involve squares of sine and cos, we convert them into normal sine and cos using multiple angle formulas and then go about doing them. And the third type, if you have tans and cots, we start with angle and solve them. This summarizes the topic of conditional identities.